This is Mr. Anderson for Kellogg Community College in our Part 3 video to look at these complex rational expressions. So, looking at this first fraction here, let's change to blue so we can look at just the top part here. Our common denominator in our first fraction, unfortunately, is just going to be multiplying our x over x plus 3 times 5x to get our common denominator of 5x and x plus 3. And then we're going to take our 4 over 5x and multiply that by x plus 3. When I do my distribution, I'm going to have 5x squared. I'm going to have plus, and do my distribution here, 4x plus 12 all over my combination of 5x times x plus 3. Let me switch to my fraction down below. So in red, my common denominator between these two are going to be x times 2x plus 6. So my first fraction, x over 2x plus 6, is going to get multiplied by x over x. And then we're going to add to that 3 over x, which is going to get multiplied by 2x plus 6 over 2x plus 6. So to do my distribution, that's going to give me x squared in the numerator. 3 times 2x is going to be 6x, and 3 times 6 is going to be 18. All over x times the quantity of 2x plus 6. It would be good to note that 2x plus 6 can also be simplified to 2 times the quantity of x plus 3, which will then change this denominator to be 2x times x plus 3. So this will actually make the next step just a little bit better. Let's go bring this up to the top using my green pen to show you what I'm going to be doing. The green pen is going to move this to the top here, and we're going to use multiplication instead of division. And let me change back to red here. Okay, so when we move this to the top here, we're going to have to flip it because instead of dividing fractions, we're going to skip, flip, and multiply. So this becomes x squared plus 6x plus 18 in my denominator. And my numerator is going to be this 2x times x plus 3. What this leaves me with when we start to do some simplifying, we are going to look at the x plus 3's, which can simplify across this diagonal. And the x's will simplify across the diagonal. And that leaves me with 2 times the quantity of 5x squared plus 4x plus 12, which might mean that you could possibly factor this, but let's wait just a little bit before doing so. Let's write our denominator 5 times x squared plus 6x plus 18, because there's no sense in trying to factor the numerator if the denominator can't be factored either. And I can't think of two numbers to multiply to make 18 and add to make 6. So since the denominator can't be factored, there's no sense in going through the process of trying to find combinations to make this middle term of 4 in the problem, so that would be our answer. Because these next two problems take a lot of writing work, I'm going to clear the screen here, and we're going to go to kind of move this to the top here. Alright, and this is going to use up a majority of space. So as I've said, in class you may want to have some lined paper for this because the work's going to get a little messy. Now, since I'm not a big fan of subtraction, I'm going to add negatives here. So changing that to add a negative, and change this to add a negative. Now, what I'm going to do here is just, before I look for a common denominator, I'm going to factor out these two in the bottom here. So this is going to be x plus, two numbers to multiply to make 10 and add to make 7 is x plus 5, x plus 2, plus a negative 2 up here. Two numbers to multiply to make 12 and add to make negative 7 is going to be x minus 3, x minus 4. Now, unfortunately, since there are no, there's no unfortunate common terms in these, then this is going to have to get multiplied by x minus 3, x minus 4, top and bottom, and this is going to have to get multiplied by x plus 5, x plus 2, top and bottom, which gives me an entire numerator, and this is going to be quite the monster here. This is going to be x minus 3 times the quantity of x minus 4 minus 2 times the quantity of x plus 5 and x plus 2 all over this, which is x plus 5, x plus 2, x minus 3, x minus 4. That's my numerator. Now, I'm going to have to really work to get this pared down a little bit, because some people might think, well, can't I just cancel out these pairs? But you can't. Because of this middle subtraction sign, this is now considered a binomial, even though it's not simplified yet. But this subtraction sign means we can't just start canceling things in the numerator and the denominator. Let's go and process this bottom one, and you're going to see kind of a neat little synergy that's going to happen here. And let's go change this into red. So I'm going to factor this out. I'm going to have my 2, and I'm going to put a line here. What two terms multiply to make -6 and add to make -1? That's going to be x minus 3, x plus 2, plus a -1 over. This is going to be two numbers to multiply to make -20 and add to make +1. This is x plus 5 and x minus 4. Alright, well, since there are no commonalities between these four terms, we're going to have to multiply this one by x plus 5, x minus 4 to get my common denominator, and multiply this by x minus 3, x plus 2 to get my common denominator. Wow, that makes my numerator just pretty hairy again. 2 times the quantity of x plus 5 and then x minus 4, minus 1 times the quantity of x minus 3 and x plus 2. And the entire thing is over x minus 3, x plus 2, x plus 5, and x minus 4. Now, I think by this time you should maybe be looking around for some commonalities, because my next step here is to bring the here, let me show this here, is to bring this up to this level. And we would do so by multiplying and flipping this on its head. But do you notice that these four different denominators and these four different denominators are exactly the same? You've noticed you could have done this in previous problems, but if your denominators are completely the same here, 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 and here, and we flip our problem, they're just going to simplify, because you'll notice they're in each one of these denominators. And so this becomes the numerator, and this becomes the denominator of our answer. So I'm not going to change to the color green, but I want to show you, using the colors blue and red, what just happened. This numerator here, this one up here that had no canceling, is x minus 3 times the quantity of x minus 4 minus 2 times the quantity of x plus 5 and x plus 2 over. Now I'm going to change this to red, even though I probably shouldn't have had that division bar in blue. Let me change that to green here. That's pretty good. Alright, let's change this to red. So this is going to be 2 times the quantity of x plus 5, x minus 4, minus the quantity of 1 times x minus 3, x plus 2. So this could have been a shortcut you could have used in earlier examples here, because by just flipping this problem and putting it up here, you'll notice that this level and this level will cancel out. The blue will be on top, the red will be on the bottom. Now our job is to do the distribution correctly. So let me switch back to blue to show you that. To do my distribution up here, I do have to FOIL this. So that's going to be x squared minus 4x minus 3x plus 12. And then I'm going to have this minus 2 times x squared plus 2x plus 5x plus 10 over. and that's where things get a little bit scary here, because we're having to do so much work here to simplify and these terms here. So I'm going to multiply 2 times x squared minus 4x plus 5x minus 20 minus x squared plus 2x minus 3x minus 6. And now we just need to put all this together. And yeah, this is going to be a little bit of work here, but we're going to make it happen here. Let's take a look at the blue term, and I'm going to write it in green. This is going to give me x, whoops, this is going to give me x squared minus 7x plus 12. And as I put this together, I'm going to double everything. Negative 2x squared. 2 and 5 makes 7, so that would be negative 14x. 10 and negative 2 make negative 20. So that is my numerator from the blue. I can then simplify that even further by going negative x squared, because I have the x and the negative 2x squared, negative 21x, and then 12 and negative 20 is going to be negative 8. Just looking to make sure everything's okay here. Alright, now let's go to the red section here. I'm going to multiply my 2 times all of this here. So x squared multiplied by 2 is 2x squared. I'm going to multiply, let's see, negative 4 and 5 make a positive 1 times 2 is positive 2. And and the 2 times the negative 20 is negative 40. Then down here, everything gets put together in opposite, so negative x squared here. The 2x minus the 3x, that's going to be, let's see, 2x minus the 3x, that is going to be negative 1x, which is going to be positive 1x, and then multiply by the negative to make it negative x. Then we have negative 6, multiply that by that, gives me a positive 6. Alright, simplify all this. 2x minus x squared is x squared. 2x minus x, that is going to be plus x. And then negative 40 and 6 is negative 36. Or negative 34, excuse me. And there's no way either or any of these can actually make the problems that we're looking for here. And I just want to make a quick check here. That seems to be okay. If I made a mistake in this, I'll maybe put a little annotation in there. Something doesn't feel right, but I know at the end of this problem we can't do any factoring whatsoever. So this is the end of the problem. Alright, let's look at problem 12. And again, I need to kind of erase all this to get us ready for the last problem here. Okay, the last problem. As far down as I can go, so I might be writing a little bit up above for this one here. So we're going to start off with factoring each of these out. I'm going to factor each of these out to see if I've got some commonalities here. So let's take my blue way up to the top here. So 2 numbers to multiply to make 12 and add to make 7. That's x plus 3 and x plus 4. Now 2 numbers to multiply to make negative 6 and add to make 1. That's going to be x plus 3 and x minus 2. This isn't going to be so bad because you'll see that there's some commonalities here. Like we won't have to get a common denominator, I'm going to be multiplying this one by x minus 2, and I'll be multiplying this side by x plus 4. So my new numerator is going to be x minus 2 plus x plus 4 all over x plus 3, x plus 4, x minus 2. Now let's go and separate this and look at the red for my denominator here. Let me see, 2 numbers to multiply to make negative 8 and add to make 2. Well, that's going to be x minus 4, x plus 4, x minus 2, or I'll just put plus negative 2. And let's see here, 2 numbers to multiply to make 4 and add to make 5. Well, that's easy, x plus 4 and then x plus 1. Alright, well, in this problem again, you're not going to have too much work here because you're going to see like these have x plus 4, x plus 2 in common, so it just needs an x plus 1. So what we have here is now x plus 1. plus, I'm going to multiply this side by x minus 2. So I'm going to have x minus 2 here. And that's over x plus 4, x minus 2, x plus 1, x plus 1. So, let's do some more simplification in each of these. Let's see if the numerator sheds some light on the picture here. Alright, so this numerator way up here, I got x and x, that makes 2x. And I got negative 2 and positive 4, which makes plus 2. All over this mess. But wait a second, if I factor out 2, that might be able to help me out later in the problem. So, that is probably good to see there. Now let's go to my denominator and see what we got here in red. I got x and x, which makes 2x here. And then I'm going to have 1 minus 2, so that gives me negative 1 there, over all this, which might give me something to cancel out there. And now what I'm going to do is I'm going to be rocking out the simplification of all this in green. So this is going to be on the first thing I write over here. Whoops, sorry, light blue, didn't mean green. So this is going to be 2 times x plus 1, just in case, over x plus 3, x plus 4, x minus 2, times the other fraction, which is going to get flipped here, so this is x plus 4. See what's going to happen. X minus 2, and then x plus 1, all over 2x minus 1. It's real sad. I was kind of hoping that there'd be some simplification here, and barring a mistake, there's nothing I can really do there but cross out this, and this, this, and this, and unfortunately there's nothing we can crisscross on this side, nor that side, so my answer here is 2 times the quantity of x plus 1, or x plus 1 quantity squared, over x plus 3 in my, and 2x minus 1 in my denominator. Alright, thanks for watching.